Hey everybody, it's Chuck Burr here with another edition of our TAPS video series. Today we're focusing on nitrogen and water and the interaction. With me today is Abia Katimbo. He's a graduate student working on his PhD with Dr. Darren Rudnick, and going to tell us a little more about the technology that he's using to make nitrogen and water decisions and their interaction.
My research is basically looking at water and nitrogen interaction in corn, specifically on TAPS fields. Behind me, this is a high clearance tractor, and this is what I'm using to really be able to answer some research objectives for my PhD dissertation. We have on this tractor, we have what we call the crop circles. So these are active optical sensors that are used to really monitor nitrogen and look at nitrogen stress in corn and also other crops. We also have infrared thermometry, and this way I talked about by Hope, I think, in the previous video series. But in this, we have a mobile infrared thermometer that everywhere we go through the plot, we can be able to get the canopy temperature as well as the vegetation indices that tell us how the crop is in terms of the nitrogen. We also have a thermal camera that also used to take a thermal image. Instead, if a farmer doesn't have the infrared thermometer, he can go ahead and process that image to get those temperatures and be able to compute the indices that can really tell us if the crop is stressed or not stressed. So every snapshot, we get a thermal image. We also get the RGB image. So the RGB image just tells us, just helps us to really focus on the canopy, just to tell us where we can be able to identify a leaf within the thermal image, because it's very hard to really know differentiate between the soil and the canopy when you're just looking at the thermal image. But if you have the RGB, you can be able to compare the two and see which features are within thermal image. Just looking at a specific sensor, the infrared thermometry is just to capture the canopy temperature, measures the canopy temperature of the crop. If the crop is stressed, we can see the high temperatures, probably sometimes about 35. But if the crop has sufficient water, so it means there's good transpiration and the crop is cooling, so the leaf will be cool and be having less degrees or low degrees on the crop. And these ones are the crop circles that kind of tell us the nitrogen, how we are in terms of the nitrogen management on a crop. So what it does, it measures different vegetation indices, which are computed from different spectral bands. But the main indices that we get off from the crop circles, we have the normalized difference red edge, which is NDRE, and then we have the normalized difference vegetation index. And then the thermal camera, it has, it is manufactured by Freya, so it has the thermal lens and also the RGB lens. So we have two images that we take. And now we have our sensing tractor on the subsurface drip irrigation system. So we have two TAPS competition, the SDI one, which is the subsurface drip irrigation system, as well as the pivot. But now we're going to show you how we collect the different data that I've talked about, the canopy temperatures as well as the vegetation indices. So the reason why we collect this data on TAPS, we are trying to see, we are evaluating the management decisions made by the farmers in terms of the application of water and nitrogen, but also looking at the interactions between the two, the nitrogen and water, and how that could impact the end yield that a farmer gets. So everyone, I'm going to just give a quick presentation about the sensing, the data we get from the sensing, the high clearance sensing tractor, the new TAPS. We're basically using it to look at water nitrogen interactions on farmers' plots. We are doing all this in collaboration with Dr. Kendall DeJong from USDA ARS in Fort Collins, Colorado. After doing all the sensing, moving all through the field, we kind of try to map out our sensing path. And then from that is where we process the data and allocate each data to the farmer's plot using the GIS software. We can, sometimes we use ArcGIS and Other times we use QGIS. So this is how it looks in the software, GIS software interface. So we have the farmers' plots, and then we have the sensing parts from which we get the values for each farm in terms of the canopy temperatures as well as the vegetation indices from the crop surface. And also the thermal camera gives us the images that look like this. We have the RGB, it gives us both the RGB and the thermal image. So the reason why this camera has the RGB image is because when you're trying to actually identify a feature, or let's say a leaf, you can relate the two images and see where you're pointing at in the thermal image, because it's not clear enough if you're only using the thermal image to really get the canopy temperatures. What we do is to import this image into the FAIR tool software, which gives us the thermal image, and then we can be able to get the temperatures by just pointing on the leaf. Here I pointed on the leaf, and at that particular time in this farm, the leaf had 28 degrees Celsius of temperature, and then the reference surface, the wet surface that I talked about earlier on, was about 27.5, almost close enough to the crop, to the temperature of the crop, and then the dry surface, which was about 57.7. So we're going to see how we compute the plant stress index from these images. From the thermal images, we can compute the crop water stress index by using this empirical formula which is the ratio of TC minus T weight and the difference between the T dry and T wet. So the T dry is the temperature of the dry surface, and the wet surface, the T wet, is the temperature of the wet surface, and TC is the temperature of the leaf. So after computing that index, if it is 0, so it's the crop water stress index has a range of 0 to 1. If a farmer is at, if the 0 meaning that the crop is non-stressed and water is sufficient, if the farmer goes beyond 0.5, then it means he's almost stressing his crop. And if the farmer gets a crop water stress index of 1, it means the crop has been really stressed. So this might hurt the yields the farmer might get after the season. So from this farm, we are seeing that a farmer is almost having a value of 0, an index of 0, which means the crop has sufficient water and it is not stressed. This farmer is really good at putting on water, which means he's not hurting the crop, and eventually will get the good yields. From all what we have seen, in conclusion, it shows that sensing has potential in managing water nitrogen application across the farms and also in this competition. It's also a very flexible method of detecting plant water and nitrogen stress. And the good thing, it provides you real-time data that can allow you to make quick decision on whether to apply water or nitrogen. And lastly, these sensors actually help you to quickly detect stress before you see it with your eyes. Thank you.
Well, there you have it. We're taking a look at water and nitrogen and the interaction between the two. This has been Chuck Burr and Abia with another TAPS video series.